This month's video's a similar sort of vein. I recently bought an old computer trainer on eBay. This is the Tandy, or Radio Shack as is more common in the US, Science Fair Microcomputer Trainer, which is quite a late launch actually for them in the early 80s. The reason I was interested in it, of course, apart from the fact it was available in the UK, was it uses the TMS 1000 series chip, which you can see in the centre here, which is effectively a PROM all-in-one mass program chip. So it's used in a number of devices, which we're going to take a look at as well as part of the history of the 1000. And it's always interesting, I think, these machines, and obviously I have a real interest in it because one of the first things I got involved with in electronics was a thing called the Chroma Chime. This is an advert for it, kit for £18. This is from Practical Electronics, December 1977. I think it came out a little bit earlier than that. So my dad and I built large numbers of these in his attic electronics room. It was his sort of sideline for a long time, was selling these made up to people. It was very often, I think I've mentioned the story before, that people would come along selling insurance and they'd walk away with 10 of these on sale or return to go and sell somewhere else. So that's sort of where you can see the TMS 1000 chip here. It was pre-programmed with all these tunes. And I was a fascinating kit. Not that I've got a lot of parts left from it though. In fact, I went hunting in the Shed of Doom, and all I could find was these in my toolbox, which are the adjustment controls and the dial for sending up. So I must have one somewhere. The hundreds we built, it's got to be one hanging around, or I'm hoping so anyway. If not, I'll keep my eyes peeled. So I'd love to be able to play those tunes again. I must have made hundreds soldering in the attic. They were also responsible for a bit of a risque advert. I think this is the only view of the circuit diagram we've got. I leave you to find it in one of the electronics magazines if you're interested in seeing the rest of the picture. But it is signed Chromatronics, so that's just the end of the circuit diagram. So the TMS 1000 itself is like I said, a fairly powerful chip that is from Texas Instruments. It's PROM programmed. It's got quite a bit of facility on it. 8K of ROM, 256 bytes of RAM, rather 256 bit of RAM, which is not a lot. Mostly internal. Then got an arithmetic logic unit. Lots of I/O. So very much like an early PIC, I suppose. So this was tentative data. I don't know when this was dated. I think got a copyright on it, 1975. So the chip was fairly early when available. It was the TMS 1000 that was in use in the Chromachime, but it was the TMS 1100 used in the Tandy trainer. Of course, the TMS 1000 is all the links will be in the notes, but it's quite widely used chip. Probably the most famous one it's used in is the Speak and Spell from Texas Instruments, but there are others as well. Probably the Mastermind, the very early one from Parker Brothers, used TMS 1000 as well, and quite a bit of work's been done on it. If you go to Sean Riddle's site, he's decapped quite a few of them to get some dumps of the die and to get the contents for quite a few of the products that used this. Unfortunately not a Chromachime, so we really need to find one of the TMSs from a Chromachime, but we'll do it. And of course the Sinclair Science Fair Microcomputer Trainer has been the subject of his I think it's quite a well studied chip. Ken Sheriff's blog has got a great look at the chip itself. It was the first commercial single chip computer in '74 with all of it on one. So the TMS 1000, available cheap in quantities. So said to be the best selling computer on the chip. Again, link below, well worth taking a look at in terms of how it came to be used in the calculators that he's looking at here. Specifically, he's organising how the RAM is organised as a set of the 16 by 16 RAM storage cells. Said it doesn't have a lot of memory to play with really, so But great read as usual from Ken. There's actually someone's done a Minecraft simulation of it as well. That's completely bonkers and well worth watching if you want to see it. And Paul Robson's done a TMS 1100 emulator, and Sean has adapted that to run a PIC microcontroller. That might be quite useful as we move on and see where we're getting to. And there is an open core for it as well if you want to do an FPGA or a similar implementation in Verilog. So quite a few opportunities to play around with this chip. Let's take a quick look at it, and then we'll come back and have a revisit of the bit of the history and the background to this particular device with Tandy. So here we have the Science Fair Microcomputer Trainer. You can see the TMS in the middle, and this one has got the battery connector in the back, but it doesn't seem to use it. The two connectors there, the black and the red one, are wired up, but they actually go to the battery feed, but there seems to be some wires here that go into this switch as well that come out here. So I'm not quite sure what they are used for, but that seems to be going to this position here on the speaker. So I'm not sure what they were doing when it was previously wired. So all we need to do is to see if we can power it up. I can use a bench 9-volt power supply, obviously. I might actually put a jack socket adaptation because this one's got a switch already, so maybe it'd be worth putting a little plug-in 9-volt connector, so we can run off of a standard adapter rather than batteries. So we're going to have to take a look through the book and see how this is wired up, because it's the keyboard is just little, you can see them, they're just little metal switch points, and they're all wired as an array for the keyboard underneath, and the CPU is wired out to its springs. So it seems to be all in position, all the wiring. So, and hopefully this is wired up for outputs to the display ready. So the keyboard one though seems to be going to different positions, so I'm going to go through the manual and see what we've got. Okay, so looking at this quickly, this is actually the negative point. If you look through the circuit, there's a common negative rail here. Seems to go through the top half of the circuit, so I assume there needs to be a wire that gets that ground back down to the this machine as well. There is a red wire there, which is actually going to another spring on the same position, so that's grounding. They used a red wire. So it is actually correctly done, because it would have come off of here up to here according to this wiring diagram in the booklet. So that is the ground position, and then the 9-volt. In order to test the lights, they actually just take the 9-volt feed, which I assume is this one. Yeah, so that switch is actually in the ground wire, is it? Funny. That is a bit unusual. Yeah, it's a bit of a hack coming out of there. I think we might restore that. Because I can't see what this switch actually does. So I might replace the switch with a jack connection. The actual microcomputer trainer was announced as new in the Radio Shack catalogue for 1985 on page, hopefully, 154. And we've got it here, and it does say new for 1985, so that's $29.85. Now, a few sites on the net do reference this being before the Japanese version of it, which was done by the Gekken electronic company based on their Denshi block series. And this was the Micom R-165. So it's basically the same machine, but if you look inside of it, the MP1312 chip has a mask label of 8127, which I'm going to assume is 27th week of 1981, whereas the Tandy has a mask label of 8423. So I think this was very early and probably adopted by they took this Japanese toy and provided in their spring range, I think, as a later development. They're quite juicy, the original Gekken ones on eBay. There've been a few listed over the few weeks, but they are the same device. This is the original manual. Actual pages are very similar. On I think page 154, we should see. Never find anything when you're looking for it, can you? There we go. So 154. If we keep that on the screen. And I'll take a little look now for the actual manual. So this is a scan of the manual, and if we look at page 173, we got the rat bashing game, and if I minimise that, you can see number 100. Obviously the actual code is exactly the same, and so are the instructions on how to run it. So it's definitely a translation from the Japanese original manual for the Gekken. This was also relaunched by the same company in 2009 as a cover project on the magazine they run, and you can see it here controlling one of their earlier projects as a robot. So it's considered a 4-bit process. It's still a popular project. So there's quite a bit. Again, all the links are down below. This one was a fascinating find. It's obviously the trainer, and he's looking at a guy from Texas who's pulled his apart and used it as a control package for test equipment. Because interestingly, although the ROM is programmed, what it's programmed with is an interpreter for a very simple programming language, which we'll take a quick look at. The command set is basically printed on the trainer itself, just here in the bottom corner, and there's 16 instructions which are basically about loading the accumulator, transferring the accumulator in our memory, some jump and a flag to allow you to skip things, and it's got a number of fixed routines in the ROM, as we would call it, which do specific things as subroutines that can be called with a call command. And most of the code's there. So it's actually an emulator running on a TMS 1000 on the underlying instruction set, which I think is quite pleasant. And just before we finish the sort of research, I think this is probably one of the most bonkers ones I've seen, as apart from the simulation of the microprocessor. This is actually a simulator for the Science Fair Microcomputer Trainer. It was done here. It says basically it was about the TMS 1000 was the only one it was able to emulate really on the Intellivision, because it is quite a slow machine, and he's got a great GIF which you can do, which shows it running on the Intellivision. So I think that's lovely. And if you've got an Intellivision, which I haven't, it's probably worth looking out and having a play with. For someone who's interested more in getting directly into the programming of the actual instruction set that's used, this is quite a good site, which is based on the Gekken kit. And it's got quite detailed on an engineering view, because obviously the Tandy trainer is more step-by-step wiring up particular experiments and then type this in and we'll show you how it works. So it's much longer, but if someone's already familiar with programming, it's quite a good description of how each of the portions works and each of the instructions and what they do, so that you can take things into the key and how the registers work. So it's a good site which I'll link to. There's a related one as well, because the Gekken kits are a huge range, not just this one. When they do loads of different kits. It's a magazine which comes with a kit, but this one I thought was fascinating. Was someone who's modded the Gekken thing to actually do.
So what we have here is a switch bank connected to the keypad of the Gekken microcontroller kit. We are very boldly moving back into the 19th century with paper punch.
Isn't that great? Again, link in there above this modding site that's worth having a little look at. They're incredibly flexible little machines, and hopefully be able to do something similar with the Tandy kit. Two other sort of resources that budding TMS 1000, I should say the Gekken and Tandy Trainer kit, because this isn't the actual TMS 1000, might like to play with. This is an online assembler, disassembler, which can assemble a code and disassemble a code back to and from its mnemonic form. So if we paste that in, we can assemble the code into this particular machine code. And there's also an online Scratch emulator, which is based on the 2009 Gekken project, which is the rebuild of it. I'd be interested to know what the chip is in the middle here. Maybe we'll try and get hold of one. We can take it apart and see what's under this bit of plastic here, because I assume it's emulating the machine somehow. I'm sure the history is fascinating, but you'd like to see the trainer running. So let's see where I got to, shall we? Well, this is actually VCC marked black, so it's obviously the clip was to go onto there, and the switch is actually in the ground plane. So I think one thing I will do is move the red wire from the ground there to make it clear. The black, we'll switch them over so it's a bit more obvious. So the black wire will be the ground wire. Just grips that. And you got a tatty bit of red wire here, which, but that will be the VCC on the chip. And I have already put the ground wire onto the ground position. So I don't see how the VCC from the chip gets anywhere else though. So I assume for the amplifier to work, if we're going to use that at any point as an audio output. There we go. So in theory, if I connect that to that with the 8-volt power supply, 9-volt power supply on, something should happen. Here we go. So we've got, don't know if that's visible. Yeah, so we got a bit on the display and something on the binary lights, but nothing. Okay, so we could have a problem with the chip, or we could just have a wiring problem. Well, we're going to have to do some debugging, see if the clock's running for a start. So we get the scope on and take a look at that. Unfortunately, despite quite a lot of effort to make sure all the wiring was done exactly as the book, I noticed some errors on the way the keyboard was wired. And there is a clock. It's a bit rough. It's not exactly a square wave, but then again, it is fairly simplistically produced. There is nothing. I think unfortunately, I have to come to the conclusion that the TMS 1000 is dead on my Tandy Trainer. It's in good condition, and it's a boxed item as well, so it does look rather nice. So I think for a future video, I might well take a look at that PIC code and see if I can put that onto a PIC. I can always mount a PIC behind the trainer in the position, wire it out to the points on the trainer, and restore this fascinating bit of history from 1985. Quite why Tandy thought they would be able to do something that is really, there's not a lot of experimentation you can do with this, because once you've wired it up as the machine with the keyboard and the display, it's that's how it works. Although you can hook it up with other wired kits to do control devices, as we've seen somebody actually used it for that. So it might be interesting to combine it with the 201 kit I've previously shown you, which I've managed to acquire, and maybe we can do some experiments. So the first task is going to be to try and work out how to get a PIC, because the chances of getting a a new TMS 1000 with the right PROM number on it is fairly remote, I think. But unless someone comes across an MP1312 with an 8423 date code or the 8127 of the Gekken, appreciate it if you've got one. I can swap this one out then, and maybe this one can be decapped. It might still be in good enough state to recover the ROM code. We'll see. So there will be a follow-up video on this topic as a minimum certainly on the PIC code. I think that would be an interesting little project to do. So till next month, that's when I'm not quite sure what we'll be covering, but I'm sure it'll be something unusual or interesting. I hope you're enjoying it. I'm Tim Gilbert, and this is my channel on retro computing.